So, Saini, it's your turn.
Thank you, Anna. Thank you, everybody, for having me here. It's a pleasure. I'm from the Competence Center here based in Ouagadougou, one of the outlets of Wascal. From my background, I'm a meteorologist who has now evolved into a climatologist in case you're looking for a tag name. So if you see my slide here, you have a small information about myself, but most importantly, I try to build a bridge between climate science information and results with application sectors, namely agriculture, energy sector, and telecommunication as well. So I'm very much interested in my research into a chain of climate science related research works. So I'm interested in climate extreme events as well as forecasting, particularly the sub-seasonal to seasonal forecasting. And I also from time to time pitch into a methodology of so developing some small tricks, statistical tricks for a better research in climate science. So I essentially focus on West Africa, and particularly also some of my works, they concern the world Sahel, going from the western coast of Senegal until the borders of Ethiopia, or North Africa. Actually, I am in the position of coordinator at Wascal, in charge of this unit that we call Observation Network and Seasonal Forecasting Unit, but also actually being the interim research director. Wascal is I can say 10 years or almost 10 years old now. And Wascal has been an institution per se in 2012 when it was ratified by all its member countries. And recently, I mean last month or last 2 months, we got also the adherence of Cape Verde, making 11 West African countries that constitute Wascal. Wascal is therefore an international institution. We have 3 pillars. We do capacity building, where we have special programs that are built and put in place in partnership with some universities in West Africa. We also conduct research and we provide climate and environmental services. And I will be pleased to show you a bit of our experience in that last domain. So, just like any organization, we are structured in such a way that we have our governing board, supported by a scientific advisory board, of course. And then we have 2 main departments, the one of research, where I sit, which is the Competence Center here in Ouagadougou. And then we have the capacity building department, which is also hosted in Accra at our headquarters with the administration. So these 2 departments, they work together, bound together by the administration, of course, but also by the students that we use to do the research and development of services. We are non-profit, of course, and definitely we try to support our member countries in everything related to research, capacity building, and climate services implementation and development and implementation as well. You will be highly welcome to the Competence Center. I'm sitting in this building, on the 3rd floor, by the way. And in case you want more information about Wascal, I think you can write to the secretary or you can write to me directly, and then I will provide details. We are not far away from the Échangeur Ouagadougou, so in case you pass by Ouagadougou, I will be happy to welcome you there. Mainly at the competence center where we do research, we also provide services, but we also develop services. We have a lot of infrastructure which is data related. So we have high performance computers and things like that, including also sensors that we share with the countries. Most importantly is that we have these 6 research domains where we do some work, and all those 6 are supported by some cross-cutting units like the observation unit that I'm heading. We have a GIS lab and remote sensing. Also, we have this infrastructure I talked about, which is embedded into our computing or data center. This is just an illustration of the type of equipment we have, and maybe in my expose I will come back on some of these things. So to come back to our business of the day, I would like to take you through this topic. How can climate services support renewable energy generation and management, particularly in West Africa? I want to discuss about the how, know-how, because I would have maybe written how do climate services support. But you see, climate services happens to be a relatively new field for the West African region, and we need to kind of always give orientation to people how they can, first of all, what it's all about and what they can pick out of it to really make the essence of what it's supposed to be in their application domain. So if you are a climate scientist, this is your show time to see how good these services are in supporting renewable energy generation and management. And if you are in the energy sector, then it's very, very important for you to understand that there are some things these services have to offer and that may be of use to you. So I begin with this report from the World Bank. It's an old one. 5 years ago, they made a wonderful report concerning electricity and access to energy per se over West Africa. I hope you read that. The idea there is that this figure shows the comparison between the sub-Saharan Africa access to electricity compared to other parts of the world. Of course, we are not up to standard, particularly when it comes to the rural areas. So West Africa is less covered, and of course, to this low coverage of our low access to electricity, we have other challenges that are embedded with it. As when you read the UN reports on population growth, there are projections that by 2050 the population of Africa will double. And of course, it comes as a kind of logic that you have an increase in demand for electricity, and that is also thought, according to this report, the World Bank report, that electricity demand may increase by 5-folds within the next 10 to 15 years, particularly in urban areas. So the essence for us to go into the details of seeing what it's all about when it comes to renewable energy or renewable electricity, where do our countries stand? You easily find that the answer to that question when you read the reports submitted to the United Nations Framework on Climate Change, the UNFCCC, in terms of the NDCs, the nationally determined contributions of individual member countries of West Africa. So this table you have here gives you the targets that the countries have promised, thanks to the work done by Stel in reading these reports fully and summarizing them in the form of this table. The countries I put in red are the member countries of WASCON, just to name them. But it's important for you to see the kind of resources, renewable energy resources that are being promised by these countries, and the amount and the quantity and capacities that they wish to implement by 2030. This figure here summarizes the whole show. So in the end, when you read those reports, you have what the situation is, so the status quo in the past few years, let's say in the past 5 to 7 years. And then you see also what promise or what wish they have to really increase their capacity in terms of renewable energy access, generation and access also within the next 10 to 20 years. Important is that the major sources of renewable energy that are cited in those reports are mainly these four. On the left hand side, it's all about hydropower energy and ocean waves, marine waves, solar energy, wind energy, and biomass energy. So the idea there is that knowing the disparity between the countries in terms of access to electricity, most of them are pledging that the next thing to look into is the rural access or rural electrification. So with this ambition here, which I find very much challenging because of the realities in the region, there is a need for integration of climate information and climate change information into their energy planning. So my first point here, where I will pause a moment to just try to look into what I have already said in terms of take-home message. The capacity of the region in generating renewable energy is low, that is well known, but the countries have put a kind of a high-level standards for themselves for the nearest future with respect to the Paris Agreement through their nationally determined contributions. And they should also take care of the fact that energy demand is always on the increase due to two major issues there, the population growth as well as climate change. So there is definitely a need for us to look into how we can bring better information into decisions that will be taken towards that purpose, while accounting for climate change, which is not a future issue. It's also something that is already on ground, so that we can also be able to facilitate their way of skipping fossil fuel into the system, like they agreed upon it in the Paris Agreement, and also the way they want to go into remote areas like the rural areas to decentralize their production as well as their management of electricity. The question there is that what does climate service or what do climate services have to offer? Are there solutions to these plans? So to answer that question, maybe we need to know what is a climate service. I will not reinvent the definition for you. When you go online at the Global Framework for Climate Services, which is a subsidy of WMO, which is you will find basic definitions they have given to climate services. Of course, there is something important to mention here. Climate services, usually the definition also changes according to the person speaking to you. So as a climate scientist, I will define it definitely in the sense that suits my purpose, but I came across other definitions that sometimes are not directly related to climate information. So in summary here, a climate service is the provision of weather and climate information to guide decision making of individuals and also organizations and countries and everybody. So said this way is just a simple way to summarize a very complex concept. You have a user which has specific needs. For example, here on the left hand side you have I give the example of maybe a user who has a specific need, and then climate information providers like the meteorology department of a country or a researcher like me who has some things to offer solutions. This information is available there, and then it passes through a medium of information outreach, and sometimes it can be individually. So and then you get the information and you know how that information can be useful to you as a user. So climate information here should be able to equip the decision and the policy that is being made in a given sector, and the sector that is tributary to climate variability and change, as well as weather. This is also a way to guide and inform adaptation to climate change within the region. The GFCS has also defined what they call the toolkit. That is an ensemble of methods and tools that put together can help one to either get the information or take advantage of the information. So this figure you have on the left-hand side on the screen here was borrowed from WMO GFCS in 2018 publication. So they suggested this diagram as a simplified way of explaining to you what the whole process is. So you have these tools here available into making or generating the information, and that information can be made available to users through some platforms. At Wascal, what we did is to suggest additional way of doing or providing climate information services. So we believe that climate information services should first of all be user commended. So first of all, the user tells you what his or her needs are, and then in the end, when the service is provided, the user should be able to provide you with a feedback on the quality, as well as we providing for the service. We also usually embed it with a scheme that shows to the user the level of confidence that is up in the service itself. And there is another thing important that we also do at Wascal is that we believe sometimes the intermediary may be a problem. So why not put a link between the beneficiary and the producer so that there is a kind of concept of co-development or co-design of climate services. So how does this toolkit fit into the renewable energy generation and management? This is what we'd like to look into. So for you to be able to really know how that toolkit can be useful to you as a renewable energy actor, you need to have maybe an understanding of what is the nexus, the climate energy nexus. And knowing the climate energy nexus is really knowing also, or having a better understanding of the complex climate system and how it relates to renewable energy generation and management. So this image or figure here summarizes, and I think you've seen this a lot. Climate scientists like to illustrate the climate system this way in a very simplified drawing to show you the interaction between the cryosphere, the biosphere, the hydrosphere, the lithosphere, and the atmosphere in the presence of the sun and the solar system, which provides usually the energy in between. The two and individual systems also has its own complexity. So anytime a method in climate science or weather information production systems are involved, they have to take into account these complexities before the information is provided. So one important thing to know is, for example, when we talk about energy generation or renewable energies, what are the points where they relate to climate and weather? This is a solar model I've picked from Wedrago and colleagues 2018, and it shows a PV panel or a PV model. And that model, when you go into details, you know what are the parameters that really affects its functionality. You have solar radiation or solar irradiance, the ambient temperature, also in our jargon we call air temperature, sunshine duration, that's the number of hours you have sunlight on a unit area on the surface, relative humidity, wind speed, and some other specific let's say events in meteorology we call SIGMET, or special events like dust haze. So if you know these things are important in determining how a panel, a solar system, a solar plant, for example, would function. One of them is here is an example I'm giving you. For example, an increase in the solar radiation will definitely say mean that you may have better output of your plant, for example. This image is a small illustration of what a PV panel plant can look like. So each of these units here has a certain sensitivity to weather and climate, but most importantly, when we concentrate on the PV panels, you know, solar radiation also is what mostly affects temperature, and air temperature, the more it increases, the less efficient your PV model, for example, will be. And that also means somewhere that your PV plant may have lower performance. Sunshine duration is a proxy of cloud cover, for example. And sometimes when there are aerosols or dust in the atmosphere, the sunlight becomes much more lower than it's expected. And therefore you have a reduction in the input irradiance. Something like wind speed also, it's very important, for example, for you to cool your modules with it. Therefore, when you have wind, sometimes it helps a lot into the efficiency of the systems. And other specific events like haze or hail that can cause some damages to the system. This is an illustration of it. Another one is when we talk of management, for example, where demand and transformation of energy are concerned. We know, for example, that the weather and climate are responsible for human, but also animal comfort, you know. And usually, the level of your comfort usually makes you to consume more or less electricity or energy, etc. So there are some works already done that show the relationship between human comfort and the consumption of electricity. This diagram here shows you, the figure on the right hand side shows you a typical relationship we have between electricity consumption over Niamey with the rate of temperature, extreme temperature, and relative humidity combined. So when you do that, you come to see a kind of coefficient of determination which is as much as 89%. There is this small work I wish you can read also. I will give you the references at the end of my talk. So Bonkane and colleagues 2018 have done a wonderful, marvelous job to give you some examples like that. When it comes to, I will just take two examples. The first one is the solar renewable energy based on solar radiation. The second one is the water management. We all know, for example, out of maybe common sense, that hydropower is much also related to how much your reservoir is filled and your reservoir capacity of having strong discharge. And that is also a function of how much rainfall your catchment receives, where your reservoir is. So this is also very important, the dependence of hydropower system, for example, to climate and weather. But also when it comes to management of it, the distribution of this, the power generation on one side, but also how water in the reservoir is being used is part of what is important. And you know that the distribution will always be according to the demand, and you have to account for subsequent use that may be done with the water for you before your reservoir is capable of producing, for example, the energy itself. So therefore, when you are managing electricity, particularly hydropower, it's not only the power generation, but it's also about the water that helps you generate the power. This is another way to show you that rainfall, for example, and rainfall information is of crucial importance to people that are in hydropower management, generation and management sectors. So I come back again to my question as to how this toolkit can be useful to you if you are in the energy, renewable energy sector, or how you can make sure that your climate science information is useful for them in case you are a climate scientist. So the first and foremost is observations and monitoring, which is a tool and a method, a combination of tools and methods that are used in our science to generate information. All starts, or everything begins here. So just like the medical doctor doesn't administrate or give you any medicine except he first of all measures your body parameters, the same way in the environment, the climate scientists have to do that. And this is an illustration for you of the types of tools that are used to do that. Observations near surface, for example, you can have flux towers, you can have offshore ships, manual synoptic stations, automatic weather stations, etc., etc. All in the name of gathering as much as information we can in the whole climate spectrum. Actually, in our jargon, we talk of essential climate variables. There are approximately 56 or so of them that are available that have to be picked so that we'll be able to really say something about the entire climate system. So for an example here, the map of the world here gives you an illustration of the global coverage of synoptic stations, the manual observation systems that we have over the globe manned by WMO and member countries. If you zoom over West Africa, you see the number of dots here, the full dots here is very few compared to the space or the area to be covered. Of course, they have a footprint, but that footprint is not enough to cover into the entire region. So recently, Wascal tried to add value to this. So this is a way also for Wascal to deliver services, climate services to its member countries. And this you can read in an open access paper that we did also to just show our experience in this practice. So we added this, and today, if you look at the blue triangles that are here on this map, they illustrate the number that was added by Wascal for its member countries, just to help in really being able to cover as much area as we can over the region to pick observations, climate variables. So it's all about the technology being used, and that technology has to do with the type of sensors, for example, but also the type of data transmission systems, because remote areas are not exempted from being covered, and today we have to be able to really make sure that remote areas also are covered. So the contribution and the added value of Wascal in this system over West Africa is to make sure that as much as remote areas are covered, but also that the access to the data should be open or should be made easy. We have two ways by which we did it when we were contributing. You have this table here showing you a very kind of user-friendly way of getting access to the information, and it's online, so you can do it easily. You don't need you can pick your information from there and make use of it as you wish. So another also important asset of climate services has to do with the near-term information. This is embedded into warning or alerts. It's all about what in our jargon we call nowcast, is the most recent information about the weather, and the next few minutes information, or 1 hour or 1 hour or so information about the weather. These short-term information and or alerts, they help reduce loss and damages, and also sometimes they help you manage your energy spike or demand spikes during the day, or be able or sometimes to really protect your infrastructure. So this is available. This is an example for you. You have a satellite imagery on one side, and then you have an area limited model, which is one of the tools we use to do the forecast. An area limited model is just a forecast, operational forecasting model. And here down you have a radar image. And these three, they work hand in hand to be able to really provide you with high quality information. So another thing also that is available for you as an asset for coming from climate services is the outlooks. So there are some seasonal to sub-seasonal to seasonal outlooks that we conduct. We do that for the nearest past. We also do it for the nearest future, so the next season or the next 2 weeks or the next 2 months, 3 months, etc. And there is a paper I will direct you to. This is a paper we've done with our colleagues from University of Augsburg, and it tells you how important seasonal forecasts can be. This is a typical case of seasonal forecast, consensus forecast that is generated. For example, these maps here, and the colors here tell you the terciles and how above normal or below normal the rainy season, the forthcoming rainy season is going to be, and based on that you can now make your decisions in terms of how you reallocate your resources in terms of energy or electricity that is generated. Another thing important that we do there is the verification part of it. So this is the typical way, for example, for us to check if, for example, the whole exercise of providing operational forecast is already having some confidence or not. So we embed our seasonal forecast with verification, and the verification will always be able to increase your confidence in the forecast. So this is the way also for us to be able to really make sure that all the users are able to not only understand the information that is provided, but also have a certain confidence on how useful it can be, how accurate it is. So we also do some typical assessments in terms of monitoring, also in terms of outlook. So here is an example to illustrate. For example, we do this suitability of this and that type of energy source over the region. So this recent paper that was published by my colleagues and Stern and ourselves to show over the region the suitability of wind energy and solar energy and the mix of the two. So this is a typical information that can be useful for any renewable energy actor in terms of the potentialities of the areas, because it's not every place that is, of course, suitable for this and that type of renewable energy. I think I will stop it here from the outlook of concerning the seasonal and sub-seasonal information, because of there are so many other things that we do that are very much useful for the renewable energy generation management. Some of them are like we look at onset of rainy seasons, cessation of the rainy seasons, extreme dry spells, etc., etc. All of these have something specific, and recently we made a publication to draw the attention of our users because of all the issues related to climate change over the region, for example. So we give information using the past data available into our hands to show that the region is also warming. So global warming is not just a hoax. It's something real that even in the region, when we use our own data, we also be able to see it. And this figure here illustrates how temperature is increasing, and most importantly, that increase is much more seen on minimum temperature trends. Likewise, there are other things. For example, this work by Lee and colleagues that shows the trend of variabilities in terms of extremes like warm nights, warm days, and diurnal temperature range, etc. This information is very, very important for you to understand that warming is a reality already happening in the region, and therefore, in terms of planning for energy plants like electricity dams or hydropower or solar energy plant implementation, you have to account for these types of information, not only future information but also near the real-time information. The same thing here for rainfall. So this is a typical graph that we share with our customers to give them an overview of what has been so far, the rainfall regime over the region. And this information is already important for you to understand why some specific issues have been happening into your energy distribution system, but also they are a good way for us to see how these trends also may affect what may happen in the future. Okay, this is also another typical example of what we do. Monitoring is sometimes we specifically address some demands coming from our customers. So here is a typical case where we look at all the rain gauges available over the region, and then we do some assessment to see how extreme rainfall, for example, is evolving. So on the left-hand side, on the right-hand side is our results, and it happened that on the left-hand side, when they used satellite imageries, they also came to the same conclusion over the same region. So this is to show you that this information is already valuable for us to be able to convince ourselves, but also make sure that the energy sector is aware that extreme events like heavy rain events are really becoming very strong over the region, and the reasons we know them. They may not be so important for you, but know that they are there, and when you're making your plans, you have to plan accordingly. So the other type of information that climate services can offer to others, to renewable energy sector, is the future trends and variability, and that is done per scenario. We all understand nowadays what a scenario is, and then based on that knowledge, we now understand what a projection is all about. So in case so if we keep on doing this way, or if we do that way, then this is how things will look like. And this is a typical work done by Sila, one of my colleagues, Sila and colleagues here in 2016, to show using the scenario we call representative concentration pathway, which is another scenario, 8.5, as you just look at the energy perturbance of the equilibrium of the Earth, and then you increase it by 8.5 megawatt per meter square, or you increase it by 4.5 megawatt per meter square. How will the temperature of the globe, or the temperature of the region, or rainfall will look like? And this is a typical information. This was done by these colleagues of mine based on the Codex experience. Codex experience is the simulation, the set of simulations that were conducted using regional climate models to be able to really inform people about local situations. So at Wascal, we did a step further to really bring some added value to this process. So in 2018, we developed the new high-resolution projections of using our WRF model, the version 3.5.1 model that we customized for the West African region. And we were able to redo the simulations at 12 kilometers now, horizontal resolution, rather than 50 or 25 kilometers of Codex. And we're able to get results that confirm Codex results. So for example here, in terms of temperature increase, which is a kind of common consensus of all models, climate models, the rate of changes are nearly the same by the end of the 21st century. But importantly, what we did is to bring some added value to precipitation simulations over the region. So it's already a good information to know that beside what Codex has given, we can also today tell you that we can say to the millimeter how much millimeter increase we'll be expecting at what region, at what side of the region, and that will already help hydropower management systems as well as planning energy and renewable energy plans and policies in the region. So here with Wascal, we believe that we added value to this process, and it's important that we understand that information is available and also useful for energy management. So this is a typical example also of what we have that is available, but also what we conducted. So this is done by one of our students. One of our Wascal students has done this work for Niger, for example, where he put in relation, he made projected trends and variability of daily energy demand over the whole Niger under certain global warming levels, 1.5, 2 degrees, 2.5, and 3 degree levels. So this already, as a policy maker or as a decision maker in the sector, in the area of renewable energy and generation and management, it's already something important that you can make use of to really better plan. Now, I will stop here and talk to you about the caveats, the limitations of climate services. Although there is something very important therein, there are also some limitations, some weaknesses. So one of the weaknesses you need to know and understand when it comes to climate information services, climate and weather information services, is that they have some uncertainties, and those uncertainties, they widen and become larger and larger as lead time as the lead time increases. So this figure here shows you a kind of illustration of a diagram putting in relationship the types of climate services that we can offer and the type of decisions that can be taken. And this here curve shows you the wider it goes, the wider we believe also the uncertainty rate in those type of information. So there are today a lot of efforts being put in getting some of the areas where large uncertainties are known to really work them out so that we can reduce uncertainties. So the subseasonal and seasonal efforts are being put in that sector in the domain of forecasting to make sure that uncertainties are reduced, but also in the future climate projections also that effort is being made. So everything cannot be painted as good, but what I used to say is how much use have we made of what has been good and positive so far, not only talking about the limitations. Another limitation also concerns the projections. I already said it, but important has been the fact that the uncertainties have not been well addressed so far. So this diagram on the left hand side was kind of an illustration of the cascade of uncertainties by Wilby and Desai, and it was updated by Hawkins in 2014. This shows you how the envelope of the uncertainties increases as you go into using the climate information into maybe this and that sector. It depends on how you make use of it, and the way you make use of it also may add uncertainties to what may come out of it. So it's important for us to know that even though climate information is very much useful, not everything that comes out of it is always accurate. So this is why every day research tends to make sure that quality is embedded with climate services. So my second take-home points are here. Weather and climate information services can support renewable energy generation and management in West Africa by first of all providing spatial-temporal information on resource availability, resource fluctuation, spikes, and also the complementarity. So in some areas where wind is not enough all year round, you can combine wind with solar energy and you have a mixed. At that time, you have no failure into your energy provision. But also, it can support it by translating and transferring the climate knowledge and its impacts for better management and planning. This is done through advisory and through know-how, because usually people complain that our jargon is very complicated and complex. So you need to be with them. This is why sometimes WASCAL has been championing the cause of having a direct link between the recipients or the beneficiaries with the producer of the information, so that they can really speak the same language and have the better understanding of what use can be done, what can be done with the available information. And also, climate services can really guide the energy, particularly renewable energy sector, to look into the opportunities in climate change, not only talking about the disastrous side of it. My last take-home message is how the two sectors can be of use to each other, because climate service is not always of high quality on one side, and renewable energy generation and management sector also has some challenges ahead. So the first way to solve this is to have a kind of the link I talked about between the producer and the user, and that can be done through a co-design and co-implementation of the services. And this can help reflect on the stakeholder ways forward to complete the integration. So each time the stakeholder was able to address or to properly tell his or her story and needs to the provider of climate services, definitely the best solutions can be provided. So today we're talking of customized climate services, that individual stakeholders have some needs and we should be able to respond to them. And also, as I said at the beginning of my show, my talk rather, the user feedback is very needed by us, by climate service providers, so they can be able to know if there is any satisfaction of the user as to what the type of climate service that was provided to him or her, and also that will help us, in case they are not satisfied, to know what was the problem and try to improve over it. Of course, another way to go about it is to increase the confidence of our users. So we do that through the use of verification schemes, which are added to a given climate service. So today at WASCAL, for example, when we give you a seasonal forecast, or we give you a 1 week forecast, particularly the 1 week forecast, when we give it out, we send it out with the confidence that is embedded with it. So we can say, for example, 90% chance that this will happen next week, and then we send it to you, and then you feed us back if that was true or not. That is important for us to know, so that we understand where it's working and where it's not working. And the last, not the least, is really capacity building, knowledge co-creation, and exchange of experience. These are assets, and they can only happen when the beneficiary of the service and the producer of the service come together. When they sit together, when they talk to each other, and they interact, that can easily be done. The last one, which I will illustrate with examples, is the way you can also sometimes convince that climate services work is really to demonstrate. So WASCAL, alongside with the Potsdam Institute for Climate Impact Research, have developed some ideas, some projects, and we developed some test beds and demonstrators. And I invite you to go to our website, for example, on the climate information for integrated renewable electricity generation, which is a project that we're implementing. We have 3 demonstrators. 2 are already installed in Niger, in Bonkuku and Sekuku, and 1 is ongoing right now. We will install it where we do the mix of hydropower and solar power in Togo. Another one also that we have is really the one we are implementing through the African Union and European Union funding, to look into household energy production, bioenergy production based on animal feces or animal waste, and then how that can also be a too cutting edge opportunity for them to also create agroecological processes like compost being used into the household farming system. Here are some references if you want to read more. And please take your time to read some of them so that you have a better understanding of what I've said right now. On this, I will pause here and entertain questions. Thank you for your attention.
Thank you very much, Bailey, for the very interesting lecture and your contribution in general to the summer school. Yeah, participants, feel free to ask questions. And one question you have already got is, Zaini, if you would mind sharing the slide with the participants so that they can recap on the content.
Please, Anna, feel free to make to distribute the lecture. There's no problem.
So, we will share this presentation together with the recording. So it will be made available. If you choose your track, select the webinar today. There you will find the recording and the slides. But most likely it will be Monday, I guess, or tomorrow. We will see. So thank you, Zaini.
Okay. Thank you very much. Thank you for having me.
Yeah, I see one question by Thierry, who asked one of the major problems in the electricity generation is the distribution system subjected to storm. Is that perspective how, I guess it's supposed to be GIS, can help to predict the occurrence of these events?
Wonderful. So this question is well understood. Thierry, thank you for your question. The issue of storms is a complex issue, and the best way to take advantage of climate services on that is the short-term alerts and warnings, which are more accurate because they are based on so many tools that are used, and also because the chaos of the atmosphere is not so much that we are able to really make better forecasts. So forecasts for the next maybe 6 hours, forecasts for the next 12 hours, 24 hours are very, very good in tracking storms for you. And they're also able to tell you how, for example, you're exposed to the potential of you being able to take a decision onto what to do in that sense. But recently, we also made a good progress in not forecasting, but in really even projections of extreme events. So what we did recently is to really develop a technique using thresholds. Thresholds defining the amount of, for example, rainfall that can cause this type of that type of havoc. And then when we make our forecast, we make sure that we target those thresholds in order to already warn our customers as what to do with. So it's not only a perspective. The perspective is that there are always continuous efforts in research to try to find a better, much accurate way of forecasting storms. But already existing are the short-term alerts and messaging that can help you really know about the occurrence of storms and how you should be able to really see what to do for it. Recently, I was discussing with these manufacturers, and they are thinking of having what they call mobile applications. So, like an off-grid that is, this is just an example, an off-grid that is mobile, you can just remove it at any point in time and put it in a secure place to avoid being damaged by a storm or being damaged by a hail event, etc. There are also assessments that we do at different time scales of what we call the hotspots of floods, for example, of drought, for example, etc. Those hotspots are very important for you to maybe avoid installing, or even when you install, you should install them at a higher at height so that they are not covered by the flood that may occur nearby, or the flash floods, or maybe river floods, etc. I hope I've answered the question. Yeah, don't worry, Cherry. I think it's when we say climate services, it's just a shortcut. It's a shortcut. We say also climate information services, and sometimes you hear people say weather and climate information services. It's all about the same thing. Thank you.
Type in. Hopefully, this answers your question.
Okay, the question. So there are three questions here because I see three interrogation marks. I will read them through. So how can we explain the low rate of access to electricity in Africa? Well, there is a chain of reasons. There is a chain of reasons, and I will redirect you to this World Bank report I briefly quoted. It has so many details there. There is the policy is there. I wouldn't say lack of leadership policy, but there are so many things there. The unfortunate thing is that climate services or climate issues are not the ones that are put forward in those in that problem. The lack of investment is there. Also, the lack of not investment per se, but the business models. Because investors are ready to invest the money they're in, but they want to make sure that the investment also brings added value, and that is one of the key issues that are not being addressed when it comes to rural access to electricity and even at the country level. And also, I can add one thing, that most of the electricity or energy sources that are available in West Africa are government owned. And today, I think there should be a way for us to encourage the private sector to go into the system. That will widen and increase the access of the rural areas into it. Alfred is asking a question here about which model of climate change prediction is appropriate in Africa. Model, if you're talking about model of climate change predictions, are you talking about the climate models, the tools that are used to make the predictions or the projections? Or model here is a the type of prediction? Can you be specific and be much clearer, Alfred?
Yeah, Alfred, maybe you can reframe your question or say what you mean by model. You might as well speak directly if you want. A stated pessimist model, for example. Can you refer to this, Saini?
Did he say something?
No, he has written something. He states pessimist model, for example.
Oh. Okay, it means here maybe Alfred is talking about the tool itself. That is the 42, for example, models that are used in the last CMIP 5 experiment. As I was late compared to the course. Okay. Okay, so Alfred has missed some.
I think you might as
So
well.
if you're talking about
Sorry.
maybe he is talking about the tools, the what we call the climate models. So if you are referring to climate models, I wouldn't say, as I'm sitting now in front of you, that this model is better than the other model. It all has to do with the adoption that is made of it. So usually we take one model or two models and then try to adapt them, considering land use, land cover changes, and some other stuff here over the region. The more boundary condition information you have, the better your model can perform. There is in literature, of course, some people that try to make an assessment using just one variable, like precipitation, to judge across models. I personally did it also in 2015 paper, for example, to find the envelope of uncertainties. But this is just one I will say, approach into the problem. So I can't say specifically if model X or model Y is better for West Africa. Terry is asking, how do we deal with the issue of reliability on different sources of information available out there? Okay. To quickly answer this question, I think one important thing about services provision is really accountability. So you cannot take a service from a service provider if he or she is not capable of guaranteeing some minimum for you. And this is why climate services are always available from a provider. And then there should be a scheme between you and your provider to guarantee the type of information that is provided, the type of climate service that is provided, and the quality that goes along with it. Of course, there are so many and various so-called climate information out there, but as maybe somebody who is not a professional of the field, you get lost and you get confused. This is why it's always good that you address your need to a particular provider and then make sure that that provider also provides you that which you need alongside the quality and guarantees also the goodness of the service that is provided. If you go out there, believe me, you'll get lost. Now, in fact, it is known in literature that data from NASA for solar radiation is quite good for designing PV systems. But sometimes when some compare with data from local stations, every 10 years, you get quite some huge differences. Yes, there is all the problem related to the use of this, I call it aggregated information coming from NASA, which usually is depicted or taken from satellite imageries and what you actually observe on the ground. And this is why usually you have to make a kind of performance assessment before you make use of it. More importantly, nowadays we do merging. So sometimes also you merge what you have locally with what you have from the real information that is available. So what the power, for example, the NASA website, well known for its radiation information, solar radiation information. You can use it to use local in situ information to see how much that is really working out, and then you can easily later on use it for upscaling. But as a person that is really in the near surface observation systems, I will always recommend that you trust what you have depicted from the local information station. That one is much accurate, because it also depicts all the realities on ground compared to what you will take from an real information like that derived from a satellite imagery or things like that.
Are there any further?
Alfred is trying to write down something, but it's been cut into pieces. So he was late for the course, and then he says, I saw climate projections 32/5000 L. You can get it.
Maybe Alfred, you can give some details here.
Yeah, as soon as I understand what he wants to say and what the question is all about, we'll try.
Once I can also enable your microphone so that you don't have to type. Alfred, if you want, you can speak directly to Zaini or just type your question in the chat. chat box, whatever you prefer. Maybe we give Alfred some minutes. Are there further questions?
Okay. Okay, Alfred, this question I wouldn't be able to give you full satisfaction because actually there is no precise answer to it. So if you are, for example, interested in using a regional climate model, for example, I would have recommended that you take the settings, for example, that you will yourself generate. Otherwise, you can have a lot of them available in the region, and whatever model you use, make sure that you do the performance assessment of it. If you are using a global model, for example, the same thing. There is no specific model we can claim being better than others over West Africa. There are attempts, so many assessments that are done by colleagues, including myself, as I said earlier, to look into, because you look at one variable or two variables and then you say, okay, based on these two variables, I will choose X and Y models, but not V and Z models, for example. This is a kind of decision you make by yourself. But today, I can't tell you if there is any model, specific model, which can be called as being the best model suitable for West Africa. I'm a climate service provider. If I do that, it's like I want to sell you something or a tool which is mine. So I tell you, oh, my model is the best of them, just pick it. That is not the purpose here. The first thing is, what do you want to study over West Africa? If you know the question to that, then maybe I can give recommendation as to what type of model. I can name models for you to really start your investigation with. This is a simple answer I can give you. I hope this is okay with you.
Zaini, so I think last questions by Thierry before we close the webinar. Maybe you can address this one.
Okay. Actually, the results we have right now, what I have shown to you is already out there, so you can get access to it. but it's for the average over the region. But we have also values for every country, and you can also have even down to maybe a sub-region in a country. All of that is possible and it's available. So some of the information there is on demand. Sometimes we make only publications to show that it's available. But yes, you can have it also per country. But what I have illustrated right away, the figure is average over sub-regions of the West Africa. So you have the Sahel, the Guinea, and then the West Africa as a whole, average over.
So thank you very much again, Zaini, for your presentation, for your interesting presentation. And to the students, if you still have questions, or maybe the next days you have some further questions, you can also address them within the discussion forum. We may forward them to Zaini, or you might as well contact Zaini directly. So we will share the recording as well as the slides, I guess, Monday.
Okay.
So thanks again, Zaini.
I will also be in the loop, right? When you share,
Yeah.
so that I can get my share.
Yes, of course.
Okay,
So
right.
have a nice afternoon,
Same to you.
and thank you very much. Bye.
Bye.